Okay, so because of the drill today, we probably didn't get to this page. So if we did fast forward to the part that we actually didn't get to. But this one, what I want to do is we're on page 92 and B, and we're finding a formula for the derivative of an inverse. And so what we need to, what is said at the top of the page on this one, and I will find that page so you can see what I'm talking about, is this. The f inverse of f of x is x. And while this seems like a common thing where you're like, yeah, of course that is, and you're just going to go along with what I'm thinking, I'm going to remind you of why that's true. So we just had talked about in class, and you might remember from previous courses, that when you have an inverse, what really happens is that x and y are switched. So if I start out from some function, and so let's say y equals 2x plus 1, its inverse, I'm switching the x and y's, will be like that. But we don't say x is equal to 2y plus 1. So what I'm going to do instead is I'm going to solve for this x. So I'm going to subtract 1 on both sides. And then I'm going to divide by 2. And I can say y is equal to, and I'm actually going to keep dividing, so this would be like 1x. So I have 1/2 x minus 1/2. Minus 1/2, I can write. Okay, so I've got, this is my original function. My inverse function, do you see where it's equal to y? F inverse of x will be 1/2 x minus 1/2. I did it again. Okay, so I've got these two functions down. And so if I said, again, f of f inverse is x, I want to show that. So if I've got, sorry, it's getting a little messy now, f of f inverse, and I'm just telling you it's equal to x, I want to show you this with something easy like this so you don't think I'm just making up. So f of f inverse. So I'm going to go up here and say f of x is 2x plus 1. But anytime we substitute, what we're actually doing is that we're substituting in this thing. So if it's f of 3, I put in 3. 2 times 3 plus 1. If it were f of x plus 2, I put in x plus 2 up here. This says f of f inverse. And I know f inverse is this, 1/2 x minus 1/2. Okay, and so I want to see what is this equal to. On the next page it says it's equal to x, but I don't see that yet, so that's what we're trying to show, that it is equal to x. Okay, so I'm just going to distribute, so I see 2 times 1/2 x is going to be x. 2 times negative 1/2 is negative 1 plus 1. Oh, buddy, things are looking good. So in this one, I would say minus 1 plus 1, I get x. So this shows you that f of f inverse is x. And you can try this with a bunch of easy ones just so you can see that, yes, this is true, not just for y equals 2x plus 1. So now let's go back and do this one. So it's saying f of f inverse is x. And so you could take your time and memorize this formula because memorizing is always good. Or what you could do is say, well, I actually know what this is. This is a function within a function. Wow. Do you see how in any function within a function, what I do is I take the derivative of the outside, so the derivative of f, and then I leave the inside alone. So I've got f inverse of x times the derivative of the inside. So this is a really weird one to write, and the reason why I'm writing these brackets is just because it's kind of hard to show this, but you can write parentheses, you can write brackets. Breakfast sounds like brackets for breakfast, and no one wants that. But this would be the derivative. So the derivative of the outside, I left the inside alone, times the derivative of the inside. And then I actually have to do the right too, because I can see it's equal to x, and the derivative of x is just 1. And so what I'm going to do then, I want to know just how to find f inverse. Do you see this right here? So what I'm going to do is, what if I divided both sides by f prime of f inverse of x. Seems like a crazy thing to do, but anything divided by itself is 1. So that means we have this formula that anytime we're wanting to know what the inverse, f inverse, but the derivative of f inverse is, it's just 1 over f prime, f inverse of x. And if you need to do this quickly so you're like, I do not remember another derivative, you can do so. But this is where it comes from. So the derivative of f inverse is 1 over f prime of f inverse of x. Okay, so in this problem, this one's saying f of x is equal to 3x plus 2. It says f prime of negative 2 is 3, and what is the value of f inverse of negative 4? So it says up here that I know f inverse is this thing, right? That's the formula f inverse, and then I'm taking the derivative. So the derivative of f inverse is 1 over f prime f inverse of x. I'm using this as a formula now. So if it's asking me f inverse of negative 4, but I want to know, there's a little tiny apostrophe here, so I want to know what the derivative is. I'm going to write 1 over f prime of f inverse of negative 4. So what I actually get is 1 over f prime. And now think of what f inverse of negative 4 is actually asking. So f inverse of negative 4. Okay, so negative 4 in my original function isn't going to be an x value. In my original function, it's going to be the y value. Because remember, inverse switches, and all I'm given is f of x is 3x plus 2. So if I had y is equal to 3x plus 2, if we're talking about the inverse, remember how the x and y switch? Like that? So if I'm putting this x value in, negative 4 is equal to 3y plus 2, right? Do you remember this? What I'm actually trying to find is this guy. So if I subtract 2 from each side, I get negative 6 is equal to 3y. Divide both sides by 3. I get y is equal to negative 2. That's what I want to do here. So it's weird because it's actually the function value for the inverse, but I know that's confusing. But all I'm actually finding is 1 over f prime of negative 2. Hey, look at that. You see how I've got that value here? So I can just substitute in what they've given me, and I get 1/3. So it's really strange, but what we're finding is the slope of the tangent at x equals negative 4 for f inverse. So it's a strange way to put this, but I can find out that my answer is 1/3 by using this formula. Okay, the next one, it's saying find the value of f inverse of 3, and again, you find the derivative of f inverse of 3. So if I go back up here to the formula, that means f inverse of 3, but I'm finding the derivative would be 1 over f prime, f inverse of x. This is 3, right? So over here, all I can see is I've got f, g, f prime, and g. But I don't see anywhere where I have f inverse of x. So you have to think about it, that the x and y switch. So I'm going to go over the graph of f, and then I'm going to go down to the y value of 3, and I can choose this x value of 1, because in my inverse function, my x and my y values switch. Now I can use the chart as normal. 1 over f prime of 1. F prime of 1 is 2. In the next one, we've got g inverse of negative 2. So I'm going to say, okay, well, g inverse negative 2, but I want to find the derivative. So I've got 1 over, I'm using the same formula as before, g prime. This time it's going to be f inverse of negative 2. And again, or I'm sorry, not f inverse, what am I talking about? These are g's. So this is going to be g inverse of negative 2. Well, if I look down here, I have no g inverse. So the only thing I can do is go to g and look where there's a y value of -2. And I can see it's right here, and my y value is 1. G prime of 1, I have a g prime. G prime of 1 is 1. 1 over 1 is 1.